Hello everyone. Today our lecture will be about iron carbide system metastable phase diagram. Let me give some information about this particular topic. Actually, iron carbide phase diagram is not a true equilibrium phase diagram because of instability of iron carbide compound. But under certain condition, iron carbide will decompose into more stable phases of iron and graphite. So the determination of metastable is like a system that having a state capable of changing to a more stable state. So I hope you understand. If you do, let's begin. Okay, this slide is about iron carbide phase diagram. So let me explain about this diagram. I think it's very important, will be very important for you. And the part of the iron carbide alloy system diagram between pure iron and iron carbide, which containing 6.67 wet percentage of carbon, is called iron carbide equilibrium diagram. The iron carbide is called also metastable phase, which I already explained on my previous slides, and it can be considered as representing equilibrium change under conditions of relatively slow heating and cooling. This diagram shows three horizontal lines which indicate isothermal reactions. Let me explain one by one each line. So first horizontal line is at 1490 Celsius degree, where peritectic reaction take place. So that means a liquid plus delta after cooling, after performing cooling, it becomes austenite structure. And second horizontal line is at 1148 degree of centigrade, where a eutectic reaction takes place. That means a liquid after cooling and heating, austenite plus cementite. So third one is third horizontal line is at 723 degree of centigrade, where eutectoid reaction take place. In this case, austenite after the cooling and heating becomes perlite here. Perlite, that means a mixture of ferrite and cementite. And I would like to explain more detail one of the portion of the diagram. Let me enlarge here like this, as you can see more. So This enlarged view of the portion of the diagram in the upper left hand corner, as you can see, the portion of the diagram is known as delta region because of the solid solution structure, that means the BCC structure. The horizontal line at temperature 1495 degrees of centigrade is for peritectic reaction, is one of the, as I can say, invariant reaction. Invariant reaction. Okay, and the maximum solubility of a carbon in BCC is 0.1 wet percentage of carbon at point M, and you can see the letter M. So the represents of carbon influences the allotropic change between delta and gamma. As the concentration of carbon in iron is increased, the temperature of allotropic change increase as well, from 1400 to 1495 at 0.1 wet percentage of carbon. On cooling, and from the point M to N, and cooling represents at the beginning of the crystal structure change from BCC to FCC alloys containing less than 0.1 wet percentage of carbon. As we know, austenite is a FCC structure. So the other portion from the M to P, as you can see the horizontal line M and P, so represents beginning of this crystal structure change by means of peritectic reaction for alloys between 0.1 wet percentage of carbon and 0.18 wet percentage of carbon. And hence from the P point to B point, also as you can see the horizontal line represents the beginning, and the end of the crystal structure change for alloys between 0.18 wet percentage of carbon and 0.5 wet percentage of carbon. The allotropic change begins and ends at the constant temperature, the temperature at 1495 degrees of centigrade. And it can be seen that any alloy containing more than 0.5 wet percentage of carbon will solidify to austenite directly. The delta solid solution and the allotropic change will be completely bypassed. So it can be seen that eutectic reaction take place at temperature 1148 degrees of centigrade. The eutectic point at 4.3 wet percentage of carbon is the eutectic temperature line, also we call eutectic point. Whenever an alloy passes this line, eutectic reaction must take place. So any liquid that is present when this line is reached must now solidify into the very fine mixture of two phases that are at either end of the horizontal line, namely austenite and iron carbide, as we call cementite. This eutectic picture, this eutectic mixture is given the name ledeburite. And below the other line is namely as eutictoid temperature line. Every alloy will consist of a mixture of ferrite and cementite. Depending on carbon content, it's a common practice to divide the iron carbide diagram into two parts. And the steel range is further subdividing by the eutictoid carbon content 0.8 wet percentage of carbon. The steel containing less than 0.8 wet percentage of carbon are called hypoeutictoid steels. So while those containing between 0.8 wet percentage of carbon to 2.11 wet percentage of carbon are called hypereutectoid steels. Please remember. Our next slide is nucleation. Maybe you know about nucleation from chemistry or physics or even from material science, but nucleation is also related with our subject too. So let's talk about nucleation. I give the picture. You can see this picture from austenite, and as a seed, a cementite become a more structurizing, and also we get the turns out the perlite. So during the transformation, new phase is formed. As different physical or even the chemical characteristics, or even different structure in our case, than parent phase. This is called as nucleation. And except that the theory